A few years ago, a friend of mine, there was an article in Time magazine. And it said that while you can disregard the historical and scientific aspects of the Bible, the moral things in it are very important, and we should keep those in mind and follow those. And so this woman who had shown me this article said, that sounds pretty good, doesn't it? I go, no. I go, because the historical and the scientific things of the Bible are the things that can be proven. The spiritual things are the things that we believe because the rest of the Bible has proven itself to be true. So, are my sins forgiven? I believe they are because it is promised to me in the Bible that has proven itself to be true by historical facts, scientific facts, and prophecies. So I can believe the Bible for those reasons. The other thing is that one of the things that the Bible says is that the wages of sin is death. So what that tells us is that if we are involved in sin in our life on a frequent manner, and if it is part of our life, the Bible seems to indicate that that will lead to death sooner than if you are not involved in those things. So, in something like the LGBT community that are involved in these kinds of things, there has been many studies that life is shorter for them, proving the Bible to be true. That's why I'm so glad to have Annalisa Reagan with us here tonight. She is a science teacher at Mount SAC, a biology teacher. You already have a fan. And she is going to talk tonight. Well, I'm going to let her tell you what she's going to be talking about tonight. But it has to do with all of the transgender stuff that we have going around at this point. So I talked with her. I had actually wanted her to speak on a different subject, but this was really on her heart, and I think it is so important with the things going on now. So without further ado, Annalisa, bring it to us.
Why you didn't want me to talk, you just continue that way we were doing. I became a biologist because I enjoy looking at life. It amazes me how things are put together. My family owns property out near Death Valley, which has the hottest temperatures in North America, 132 degrees, okay? And yet there's plants out there. When it's 132, can the plants pick up their roots and walk into the air conditioner and get a glass of water? No, they're stuck there. And that so amazed me that God could make something that could survive that, because I can't. I couldn't. We went out one weekend, and I woke up, and it was super bright, and I went outside. I was a little kid, and I'm walking around, and there's nobody outside, and I walk in, and I'm trying to wake everybody up. It's like, go away, go away. It was like 6 in the morning, and it was already 100 degrees. And we packed up, and we went home. We didn't even stay out there 24 hours. It was so hot. And yet again, these plants live there year-round. What's so amazing about the desert is not only do you have these incredibly hot temperatures in the summer, you have really low temperatures in the winter. It is not uncommon for certain deserts in the world to go 100 degrees variation within a day. So you could start off at 20 degrees in the morning and end up at 120 in the afternoon and have such a huge swing, okay? That's the definition of a desert, huge variation. So again, I studied desert plants for my master's degree, and that was always my interest was plants, because again, how could these things, they can't move, survive these incredible variations in the environment? And the more I learned about biology, the more I learned how amazing we're created. Unfortunately, that's not how it's taught these days. Evolution is the framework upon which all classes are built, which is really a shame because it takes away the beauty, so much beauty that's there. And my daughter's currently taking major biology, and I love getting to talk to her about all this behind-the-scenes stuff about what's wrong with what the teacher's telling her. You can learn what the teacher says because you need to know the words, you need to be able to talk the lingo, but we can talk about what's lacking in these theories. But what I've been noticing lately that's really bothered me is that I'm getting this impression that the newspapers, the media, stuff like that is telling us that men and women are the same, or you can switch, or if I feel something one way, well, I'm that way that day, and if I feel something else tomorrow, well, I'm that tomorrow. And so that it's this fluid thing, or it's how I feel, or it's what I'm thinking, or how I identify, right? That's the word that we use, how I identify. So I would like to say, contrast, that you were created specifically. There's a whole mess of verses about being created that I'm sure Mom's going to go over later, about how God formed us and knew us in the womb, that we were fearfully and wonderfully made, male and female. He created them, right? So that's what we know, and that's the truth. And so I just wanted to come talk to you from a perspective of biology. I got everything I'm giving you today, I have the references for. Some of it came off of Wikipedia, which is a very, very liberal source, a very woke source of information, and yet that's supporting me today, is Wikipedia. Okay? You cannot go against the data that I'm going to talk about today. So let's just start really soft and easy. I want everybody to stand in a line across the back of the room by height, all right? Can you just say this morning, I feel tall, and go to that end of the line, and this morning I feel short, and go to that end of the line? Is that something you can change about yourself?
Surgery.
Okay? So this is a genetic trait that we're looking at right here. It's a genetic trait that you were born with. Now, it's environmentally influenced. Maybe your mom didn't give you any calcium, right? And you had rickets. Or right, you don't get enough vitamin D or something like that, right? You get more calcium and you could be hunched over, maybe you have osteoporosis, you might not be standing still. Okay, but this is a genetic trait. Do you notice anything in the breakdown of male and female in this line? Women are short. Which is good, we need that.
Yes.
So here's something very simple, and you guys see this every day. Every day you see that men, males, are taller on average, about 10% taller on average than females in the United States. Okay? Every different culture might have different variations, but here in the States, males are on average about 10% taller. Okay? Great. So another very, very simple thing you can see right off the bat is there tends to be a difference between male and female hands. Okay?
Yes.
So this is Ron's right hand. Okay, this is my hand. Do you guys? So it's the same hand, your thumbs on the same side. You see any differences? Look at this finger and this finger.
Fascinating. His are more curved. Yours are straight. No, it's true. You want to see how it's the shape is different.
You have really long fingers.
I do.
Yeah.
Play the piano. But notice on my hand that my second and fourth finger, digit 2 and 4,
Yeah.
are about the same size and they're short. Now look at Ron, how this finger is almost the same as his middle finger. Okay? So even in somebody's hands, you can see differences. Okay? Male or female?
Oh,
Why?
Because finger looks longer. Pointer finger looks longer.
Okay, good. Anybody else gonna vote?
Definitely a woman's head.
Ooh, 50-50. 2 votes for male and 2 votes for female. Okay, turn around. Okay, why? Okay, and fingers and thicker. No noticeable fingernail. And
Finger, middle finger, and ring finger, like closer.
yep, these 2 fingers are much closer inside. Okay? But I like to talk even more in depth about differences between men and women. To me, the term male would be assigned to a man. Men are male and women are female. I do not, as a biologist, see that you can float around and change that label. Okay? And I see that also on the inside. We did some very simple things on the outside, your height and hands, things like that. When we were singing today, we had 2 people up here singing. There was a gentleman playing guitar, and there was a lady who was singing. If I asked you to close your eyes and only one of them was singing, could you have told them apart? Totally. There was a very, very strong difference in their voices, and that's totally normal and common, right? So first what we need to do is we need to figure out how to define what is a male and what is female, so we have terms that are consistent. Because that's what biology is memorizing one less terms, right? As if you had a biology class at home. We'll get it later. So we need to figure out a baseline. We need to talk about what a male is, what a female is, so we're all on the same page. So when I say I'm female, I'm a woman, what do you know about my genetics? Yeah. Okay, I can have kids. Good. I am specifically designed, my body is designed to get pregnant and have children. There's a lot of physiological differences about me and about my husband. Okay, good. But we're going to talk about several different aspects of biology, and we're going to start with genetics. So number 1 is genetics. So genetically, I am a female, I'm a woman. What does that tell you about me? Okay, say that again. I have a X chromosome. I have 2 X chromosomes, right? So in every single cell of my body, except my egg cells, which I don't know if I'm making more. I'm getting a little older. So every single cell of my body, I have pairs of chromosomes, right? I have 1 set from my dad, and I have 1 set from my mom, which are called homologous chromosomes. Remember that? Oh my gosh. So what's my diploid number? How many chromosomes do I have in every cell in my body? 46. Very good. And when I made eggs, how many chromosomes were in my eggs? 23. There's 23. It has to cut by meiosis. Remember, after reduction division, you have to cut the amount of DNA in half. Okay. So in every single cell of my body, except my gametes, my sperm and egg, I have 46 chromosomes. I have 46 chromosomes, which is 23 pairs. And the last set, when we always put them in order, are called my sex chromosomes. Okay. So I have my autosomes, which is the first 22 pairs, which is numbers pairs 1 through 22, and then the last pair, that 23rd pair, is either an XX if you're female, or what is it if you're male? XY. XY. And we call it a Y. We provide it like that, but actually, if you were to look at it in real life, on a picture which I have on that page, you'll notice that the Y chromosome is actually smaller. There's a big chunk of information on the X chromosome that's lacking on the Y chromosome, which we're going to talk about tonight. Okay? There's a huge genetic difference between me and my husband. We both have an X. Both my husband and I each have an X, but because he has a Y chromosome, there's only one set of genes for these traits, right? That's what homologous chromosomes are. They have the same genes. It might be different forms of a gene. Remember alleles? Blue eyes, brown eyes, curly hair, straight hair. Okay, so those are alleles. It's different information. Same gene. It codes for the same type of thing. But I could have chocolate cake, vanilla cake, strawberry cake, lemon cake. Okay, those are all flavors of cake. So those are what we call alleles. The gene codes for the flavor of cake, but I can have different flavors, and that's an allele. So on these genes right here, while every single gene in my body, I have two of them, because I have these pairs of chromosomes. A man only has one gene for any trace that would be in this box, because there's no corresponding location on the Y chromosome. Okay? But also, there's at least 100 or so plus genes that are unique on a Y chromosome. So all the men in this room have information that I don't have. There's information for maleness that exists on this chromosome that lacks on the X. So even though every single person in this room has an X chromosome, and we have all those same genes, only men, only males, have a Y chromosome. And you have unique information in your body that I will never have. And that makes you male. So biologically, what makes somebody male is the presence of a Y chromosome. And what makes somebody female is the absence of a Y chromosome. And that's what I have on top of the page, right? What is male men? And again, I'd say to you that male and men is synonymous. I do not distinguish between sex and gender. To me, it's the same thing. I know some people choose to have a different external outside, and that we can discuss that. But when it comes to your physiology, when it comes to your makeup, when it comes to the amount of red blood cells in your body, it's determined by this thing, this X and Y chromosomes that we have right here. Okay? So let's look at sometimes when there's something that's atypical. So remember how many chromosomes you have in your body? Does anybody know somebody that doesn't have 46 chromosomes in every cell? Yes. Exactly. Do you know somebody with Downs?
Yeah, brother.
Okay.
Yeah.
And how's he doing?
Well, actually, he passed away, so.
Yes. Yes, I'm sorry. So Down syndrome is when you have an extra chromosome. So on the bottom of this, the middle bottom of this page, thank you very much for talking to the voice. You'll see these pairs of chromosomes. Okay? And with Down syndrome, it's somebody will get an extra 21st chromosome. So you would have you'd have 46 plus 1. So you actually have 47 chromosomes if you have Down syndrome. And unfortunately, it causes a lot of cardiovascular problems, a lot of heart problems, and there's a very traditional face. The eyes are a little bit different shaped than everybody else in the family and stuff like that. And unfortunately, it's not uncommon they pass away. I had a niece that had Downs, and she was wheelchair ridden her whole life and passed away in her teens. So just one chromosome extra or less can cause quite a lot of issues, which is why we have that special reduction division, meiosis, to cut the amount of chromosomes in half, right? Well, just like with Down syndrome, other times a chromosome isn't properly divided in meiosis, and we can end up with more than 46 or less than 46. Okay? So let's look. Sometimes those changes happen with the sex chromosomes. So the first one I have listed is Turner syndrome. And what is your chromosome happens if you have Turners? So what do I mean by O? Pardon? Oh, that's cute. It means nothing. You have an X and then nothing. It's a 0. It's not an O or a that's a 0. So there was the meiosis didn't happen properly, and when those 46 chromosomes were being divided, the sex chromosomes, the two sex chromosomes got pulled into one cell, and then the other egg had none at all, right? So it's X and then nothing. So let's look at what this person looks like and feels like, this person with Turner. What does it say?
Read out loud.
Pardon?
Sorry, did you want me to read that out loud?
Yeah, or just like read a few of the characteristics.
The Turner syndrome, right?
Turner,
So, individuals are girls with a thick fold of skin on each side of the neck. They are short and stocky, abnormal ovaries, no production of eggs, and have no breast developments. Occurs in 2,500 female births.
Okay. What sex is somebody with Turners? They're female. It's very clear. This is from my Mount San Antonio biology book that I teach out of right now. So here's somebody that has an anomaly, right? They have 45 chromosomes, and yet they're female. Very clearly, it says it. Individuals are girls, and at the end it says it occurs in 1 in 2,500 female births, right? So this is very clearly still a woman, even if her DNA is a little bit different than yours. Okay, next one, Jacobs. Anybody read that one for me?
I read it. Individuals are often tall males, have large hands and feet with fairly normal mental ability, but may have learning disabilities and normal sexual development. Occurs in 1 to 850 male births.
Okay. So somebody now has an extra chromosome. They actually have 47 chromosomes in every cell of their body. Okay? What is their sex? They're male. Okay? Very clearly, individuals are tall males. Occurs in 1 in 850 male births. Kleinfelter.
Individuals are male, often tall with long legs, usually surrounded with small testicles and penis. Most other traits appear normal. Occurs in 1 out of 500 to 1 out of 1,000 male births.
Awesome. Somebody with a Kleinfelter. What sex are they? They're male. Are they going to have kids? No, sorry. But functioning male. This is how you, by the way, it's a biology teacher. This is how you get male calico cats. They're very, very, very rare. And they often have really long legs and they're sterile because male calico cats have Klinefelter. The genes for color are on the sex chromosomes. So a female cat with calico is fully black and fully orange at the same time. So the only way you can get a male calico cat is if he has Klinefelters, because then he has the gene for black and the gene for orange, but he's also male. So you can't just breed calico cats together because they're sterile. Sorry. I would have done however if it was possible, because that's my favorite color of cat. Okay, Meta X, what is her genotype? How many chromosomes does she have? 47. Okay. And what sex is she? What gender is she? She's female. Okay, tall, irregular menstrual cycles, may have kids, may not, just sort of depends. Early menopause, 1 in 1,000 female births. Okay? So this picture here, the next is actually one of those syndromes. Which one is it?
Klein filter?
So one person said Turner, which would mean one X and then nothing. But I see how many X's? 2 and a Y. So this is actually Klein. So what sex is this person? With this karyotype? This is a male. So this is a male's genes all after all their chromosomes, their metaphase, and when they're all condensed, they tease them out in a big picture. Okay? So we just defined what is male and female. If you have a Y chromosome, you have one Y, or you have two Ys, right? All these people are male. And if you have two X's, or one X, or three X, you are female. Okay? Not sex, says so. Okay? Because males only have one X, and because this Y chromosome is smaller, and again, you can see how much smaller, it's less than half as big, right? It's itty bitty little Y versus the size of the X, right? So just imagine a phone book as big as the Y chromosome versus a phone book as big as the X chromosome. The X is going to have more information on it because it's bigger, it has more space, right? Maybe you don't understand it anymore because phones are the same size, but they have different storage with that itty bitty little thing on the inside. But me, who used chalk and stuff normally when I would teach, that Y chromosome is small and can't carry as much information. So it is not uncommon for certain genes to be carried on the sex chromosomes. So here in cats, we have color, black and orange is carried on the sex chromosomes. But there's other things that can be carried on the sex chromosomes, like hemophilia. Does anybody know what it's like if you have hemophilia?
Bleed easily.
What is it?
Problem with your red blood cells?
It's a problem with your blood, exactly. And the word tells you that. Hemophilia means that if you get a cut, you don't make a scab. So a very small cut, you could bleed to death, right? Did you hear about a royal family that had problems with that?
Romanovs.
Great history. European royal family, I believe it was Britain, they brought a lady in from another part of Europe, and she was what's called a carrier for hemophilia. She was normal because the gene for hemophilia occurs on the sex chromosome. So she was normal, but she carried a gene for hemophilia. Capital H is normal. But what's interesting with hemophilia is a man only has one gene, right? Because the hemophilia gene is located on this part of the X, where there's nothing there on the Y. There's just no information there. So this is one of the genes that a man only has one copy of. So whatever he got from his mom, because a man's X comes from his mom and his Y comes from his dad. Whatever he got from his mom is the only one gene he has. You only need one good gene, one normal gene, to have normal blood clotting. It takes two genes to have hemophilia. For a woman to have hemophilia, what do you know about her dad? He had to have it, and her mom had to at least be a carrier, right? Well, way back a few hundred years ago, men didn't live to sexual maturity if they had hemophilia, if they never had children. So this woman comes in as a carrier. In the British royal family, they used to marry cousins and things to keep all the money in the family. right? And so very quickly, hemophilia spread through, and they started having problems and losing their sons. They didn't have problems losing their daughters, again, because the dad has to have hemophilia to have a daughter. I wanted you to know that hemophilia is not the only gene that's carried on the X chromosome that has no corresponding gene on the Y chromosome. I listed them for you. And it took a whole page. So the whole second page are just genes that men are more susceptible to express than women, because men only have one copy. So whatever you got from your mom is the only one copy that you get. Okay, that's a very long list. We're not going to discuss it. I just wanted you to know how long it was. That's why they're there. And this came off Wikipedia. And you can go and look later. So men are much more common to be colorblind. Anybody in here colorblind? 2 people raise their hand and you're both men. Okay? It's very uncommon for a woman to be colorblind. Again, it means that her dad has to be colorblind and her mom has to at least be carried, right? Have to have 2 sets of genes to express that. So no matter how you feel, no matter how you identify, if you are male, you are much more likely to express more certain genetic traits than I am. Okay, just because of the fact that you're male. You guys remember transcription and translation? Codons, anticodons, transfer RNA, messenger RNA. You guys forgot.
You know the Mr. Merman?
Who?
The department chair, Mr. Merman?
I don't know anybody.
What's that?
Oh, Merman.
David Merman.
Yes, of course you
Here's my
know.
biology.
Very cool. Yes. Okay. So if you remember from high school biology, we have all this information in our DNA, and then your body takes that information and makes it into protein, expresses it, right? Okay. So what we found is, even though we have an incredibly similar genotype, even though men and women are only different based on that one little Y or not, all the other chromosomes are the same. You would think that we're really similar, right? When we look at how your body expresses those genes, how your body uses those genes, there's a huge difference. So my next reference is an article, top of the next page. It says researchers identify 6,500 genes that are expressed differently in men and women. So what they did is they looked at 20,000 genes that men and women have in common. And of those 20,000 genes, more than a third of them, right? 6, see, well, almost a third of them, okay. A third of them are expressed differently. So I have the genes for hair, right? But do I have as much hair on my body as a man, the average man does? No. I have the genes for muscles. Okay, I make muscle. But do I have as much muscle mass as a man does? No. I have the genes for fat. Okay, I have way more fat on me than the average man does. Okay, so even though we have the same genes, we have the same information in our cells, we have the same recipes. My body makes certain recipes more than your body does if you're a guy. Okay, so this whole idea of, well, the genes are the same. Yes, but how do we express them? Evolutionists use that with, oh, we have so much in common with monkeys. We have all these same genes. Yes, I make hair, monkeys make hair. But you know what? Monkeys make a little bit more hair than I do, okay? So I think that that is not the same because it's expressed differently. Information may be there, right? Okay, so you can think of a cookbook and how spicy you like your food, right? And certain people cook super spicy and they use certain recipes, other people don't. So it's the exact same thing with our bodies. We all have similar information, but men and women use that information differently. And I gave you the reference. You can actually go and read the article in Journal of Biomedical Chemistry, whatever that is. Okay. So you can see, actually, we listed the 6 differences: testes, prostate, reproductive system, skin, brain, and gland tissue are expressed differently in men and women, even though we have the same recipes. We express them differently. And then here I just got this list right off of Wikipedia. I love this. They can't hide this stuff. So, men on average are 15% heavier. They have about a 10% higher metabolic rate, which is why we're always complaining about not being able to eat. You're eating like crazy. Okay, so fine. I make extra calories into fat. Men just sitting there making it into muscle. It's disgusting. Females, we only have half of your upper body strength. I've got about 3/4 of your lower body strength, okay, on average. If you're taller, we talked about that before, men on average are about 10% taller. You have a greater lung capacity than I do. Your hearts are bigger. Not that it means you're better lovers. It just means that your hearts are bigger. You have more red blood cells than I do. Just sitting there. Pop. You have better clotting factors than I do. You heal more quickly. You feel less pain than I do because of how your body heals faster. The neener, I make more white blood cells than you do. I have less chance of getting an infection than you do. I actually have a better immune system than you do. Finally, I found something that I can do better than you. It took me a really, really long time to find that. Okay. So hematocrit is an actual measure of the red blood cells in your body. And so from the Red Cross, again, I found a non-Wikipedia reference here, from the Red Cross says that an average man's hematocrit, which again is what percent of your blood is cells, your hematocrit is 40 to 50%. So your blood is almost half red blood cells, whereas mine is less, 36 to 48. You have more hemoglobin and all that kind of stuff. So what I want to talk about and what I want to measure is lung volume. So average man has lungs of about 6 liters. Average woman has lungs of about 4 liters. So let's see if Wikipedia is true. I got it, sorry. So what I have is a bottle of, that's now cold water, and labeled upside down, I have the volume. So in half-liter increments, I labeled the size of this bottle. And what everybody's going to do, and again, everybody's welcome to do this after if you're willing to use a mouthwash, is you're going to exhale. Nobody's going to inhale this water that who knows where it came from. You're going to exhale, and I'm going to catch all the air in your lungs. Okay? So you're going to take a few big, huge breaths, a really nice, big, huge, and then you're going to push every little drop out. It's got 2.4. 2.4 liters for Megan. So you see how this works, right? She exhaled, displaced the air, and then I can measure it based on the lines. Okay? And I'm going to do 2. You get to keep your 2 as your souvenir. No inhaling. You're going to plug your nose. 1 huge gigantic breath.
I'm placing bets. He's got a 3.2. He's got a 3.2.
Don't make them laugh. It's really hard to exhale when you're laughing. Good job. Wow. Where's the water?
Air that stopped blowing.
Yeah.
Air and empty air. So
4.5. 4.5 liters.
How is swimmer? I guess it's like his thing. Oh.
What is it?
Oh my gosh. I just died. About 4.1.
LAPD right here.
Free. Let it cook.
I want to put it dinner.
4.25.
Oh.
What's the average for the girls?
See?
So what we noticed on that next page, it says physiology. Men have bigger hearts, men have more red blood cells, men have a higher lung capacity. Okay, does that give men any advantage at anything? Sports. Any sport that has to do with what? Swimming, running, fast, soccer, strength. Okay, have you guys heard of a gentleman that goes by the name of Leah Thomas? Who's a fully intact male who just puts on a woman's bathing suit and races against women. And what has he done with all the women's records?
Broken up.
Shattered them, because he has a 20% bigger heart and 25% more red blood cells and 50% greater lung capacity. Okay, and have you seen how tall he is? Okay, okay. So this is what's being presented to you as truth, as reality, as normal, as okay. And yet, biologically, it makes no sense to me whatsoever. He has a huge competitive advantage over all of the women that he's competing against. That's why we have women's sports, is because we are made differently.
So Annalise, so your point is that no matter what kind of surgery or whatever kind of procedures he might have, he's still going to have all those same advantages you talked about, right?
If anybody has gone through puberty, if any person has gone through puberty, these things are set. A lot of these things are set.
So no matter what procedure they have after that point, it's not going to really make a difference.
It won't make a difference enough to bring a man down to a woman's level.
Okay.
And there are certain things that I'm going to talk about next that don't even change with or without puberty.
Okay.
And that is both, which is our next page. So this is a cool picture. And it's a good, appropriate picture because the woman's shorter than the guy, which we know women are on average 10% shorter than men. Nothing wrong with that. So we can talk about this picture. There's a lot of things in this picture. One, men and women's skulls are different, which we're gonna walk you through an activity, or you can do it at home. Run out of time. But you can, if someone's gone through puberty and I find a skull, I can figure out what sex you are based on your skull at a very high percentage. Okay, if you've gone through puberty, even before you've gone through puberty, if I find your pelvis in a CSI situation, right, I can tell if you're male or female. So the pelvis is set even without going through puberty. Our bones are different at birth. This article, dated in 2015, that women are born with a 10% smaller spine than men. So from the very beginning, my bones are smaller and they're weaker. And what do women, as we age, are more likely to get that affects our bones? Osteoporosis. So even I was born with a greater tendency to get osteoporosis, even before I go through menopause. The choice of menopause. I already have a weaker skeleton than a man does, okay, at birth. So that came from our local children's hospital. Next page. CSI, estimation of genders of human skeleton. So I bolded it, and later, distinction between male and female body based on the pelvis provides the highest accuracy, almost 100%. Okay? So what is it about a male and female pelvis? So, this is your pelvis. I can tell you the name of the bones. It's 3 bones. Immerse. Ischium. Okay. Yay. I'm a botanist, right? So your pelvis is a really important structure for a few reasons. The base of your spine is back here, so all the weight of your back is going to be sitting on this. It's an important structure. Also, I have this really cool little cup right here. What bone fits into that? Okay. Femur. So notice it's got this beautiful little ball on the top. Hence it's called a what joint?
Ball joint.
Ball and socket joint. Okay. So the top of your femur, the largest bone in your body, fits into this cup. And that's how you walk. And it's got this really cool thing that it's been 360 degrees, the ball and socket joint. It's an amazing thing that allows incredible motion. Okay, so your pelvis is really, really important. And so your ability to walk, your ability to stand upright and support your weight, all this stuff is happening in your pelvis. Bones are really cool. Wherever bones have extra little bumps and big, huge spaces, it's for muscle attachment, right? So look at this big, huge, flat surface for your rear end muscles to attach, okay? So this is a huge, important muscle. Otherwise, this would be really small. This could just be tiny, right? But you've got this huge flare on here. So this is for muscle attachment. This is a very important site for muscle attachment for all these muscles that go down your leg and front too, right? Okay, I never had human anatomy or physiology. I went builds it all up.
Mhm.
So again, but whenever bones have big bumps, that means there's a very important muscle attached right there. The bigger the bump, the bigger the muscle could be. If you feel the back of your head, it's perfectly smooth. The back of this skull is perfectly smooth. But if I have the skull of a bear here, which we have at Mount Sac, the advertisement for Mount Sac, there's a ridge on there's like a roof and the back of the skull. Have you ever seen the neck of a bear? How strong they are? They grab their prey and shake it. Okay? They actually have extra ridges and bumps on their skull where their neck muscles attach. So that's what I'm explaining about, that this is a really important muscle attachment. So, if you look at this pelvis, you can see that these muscle attachment places, which affect how you walk, are at a certain angle, right? And look at it that way. Whereas when I look at these ones, what do you notice about the angle? It's all different. A little bit more of like a V, these are more flared out, the way these are, versus this one. See it now? It's a little more upright. Okay. When I walk, my butt swings back and forth. And the pelvis inside of me causes me to move this way. I actually do this. I'm not trying to be sexy or alluring. I just naturally walk, and my butt actually moves back and forth. This is how I walk. When my husband walks, he doesn't swing at all, right? He just goes like any man that I have come up here. There's a total different motion to their hips. I have to bend my knees and walk with my thighs instead of my butt when I walk like that. My insides are totally different. That was set at birth. My pelvis is set at birth. The paper that talks about CSI said all I have to do is find a pelvis and I'm 98% accurate at determining the sex. After puberty, I can use the skull. So your skull changes with puberty, the pelvis doesn't. Okay? This is a man's pelvis. Their hips tend to be narrower. Okay? Sorry, that's a woman's pelvis. And then look down. I have to look down. Maybe you can see it from the side and I have to look down. Okay, let's start over again. This is a man's pelvis. Okay? Much more upright. They tend to have a narrower pelvis. Of course, they don't put as much fat on. Those are girls. And then here's a girl. It's totally different. But what's important is when we look inside. Okay? This is the hole that your intestines, your colon, you pee, all that stuff is going coming straight down. So you have a pubic bone right here. Okay? There's nothing in front of that bone. All the tubes are back behind it. So the bladder, the colon, and everything empties through that hole, right? Okay, this is a man's pelvis. But look at a girl. Look at the hole that's created in a woman's pelvis. Because what else has to pass through that besides just urine and feces? A child. Okay? I am designed, I am optimized to have a child. My pelvis is different. The angle of my knee is different. The angle of my femur comes out of my body is different. If I was to put a vagina into this person, could they ever have a baby? No. And this is set at birth. Yes, if you take estrogen, it relaxes it a little bit. Yes. Okay. But this the angles and stuff is set. Okay? So there's a huge difference. You can see that then in the picture on the previous page. It's talking about this Q angle. So my knee is put together differently than man's knee. My center of gravity is different. I walk differently. My bones are thinner. And this is set. If I go through puberty, this is all set. So you can see that men have a huge competitive advantage when it comes to anything to do with strength, endurance, and things like that. They have a greater reach. There's even more things we could do. Men tend to have longer arms for the same height. And there's a lot of fun stuff we could measure. But I was trying to choose ones to sort of make a point. The next thing has to do with the skull and the pelvis. So this is a activity that the Smithsonian put out. Okay, the Smithsonian, the United Museum, Smithsonian, right? Okay. So you can see that they took the bones of the pelvis. They're comparing the female and male pelvis. And you actually have pictures because, anthropology, we're looking to see, we go into certain cultures, are they mostly male, are they mostly female? They found islands where it's all guys, so they're trying to figure out why that is. And we can figure that out with their bones, right? And then we also know that there's quite a difference with skulls. Okay, the angle of the chin, the depth of the eyebrows, things like that. You'll notice difference between male and female skulls. So this first one is man has a much more square jaw and a larger brow ridge. The next page is female. The jaw tends to be more pointed and the brow is flatter. And then you at home can go through this. And here's an actual skull that they have. So here's a skull, and you could look through and see, is it male or female? In a beautiful color picture. Okay. Anybody have any questions?
What happens if it's a double Y?
Was that one of them? X,
No.
Y, Y?
No, I was.
That was Jacob? Oh, can you have just Y? Is that what you're asking?
Yeah.
Okay, that's a great question. So again, if you look at the pictures, you'll see all this X, how big the X is. There's some really important stuff on your X chromosome, and without an X chromosome, the baby won't make it. So if that mistake happens, she'll have a miscarriage and the child won't even develop. So Y0, YY, none of that has enough information to make a person. Good question. Yeah.
So like, what is if someone were like on the opposite of the argument where they said like there's skulls that are found that are like almost humanoid or like more like humanoid, and like it's like in between. Like,
So you're talking about evolution, the evidence for evolution,
yeah,
okay?
yeah, like a skull like Lucy, basically.
Uh-huh.
Like what's going on there?
It's a great question. I haven't read about that. I don't know. I haven't had those classes. But certainly we are affected a lot by our environment. So, when I was pregnant, I ate a certain way and I ate a lot of spinach, beef, and all these things that I wanted so that my babies were perfect. I didn't gain too much weight, so they didn't get too big. There's all these things. So even when we have genetic traits, things can still happen. I know a gentleman that had a brain tumor when he was young. He was maybe 6 or 7, and his whole face, it grew super fast before they could get it out, and his face expanded, and his eyes are in a different plane, and the one's even twisted. And he's an amazing artist. It's Houseworth's son. He lives in Colorado. He's an amazing artist, and his eyes are not level. I don't know how he does it. But they were able to get the tumor out, and they helped him. So obviously when this man passes away, he's going to have this really unusual skull. Well, it had nothing to do with genetics. He had cancer, and it was an environmental thing. It wasn't a genetic thing. He's no missing link.
Yeah.
So you have to have all those things in mind, and it's also the whole picture. If I can show you examples of evolution that look really good, homologies and conversion evolution, coevolution. I can like stand here and try to make it sound good. But what the theory of evolution says is that there was nothing, and it exploded and it became everything. And it was and then through time, and all this insane amount of time, that something that was totally unorganized and had no form, without form or void, that's what it says in the Bible, that this thing somehow started to create its own order. It became more organized. And then through time, all of a sudden now I have a simple cell that is very simple, like a bacteria, super tiny, small, but it has DNA in it. And then that cell became more complicated by bringing in other cells. And then it became more complicated by becoming multicellular. And then it became photosynthetic versus cellular respiration. And something with no organization became over 10 trillion cells in insanely organized and the ability to be rational and think and remember where I left my checkbook. So that beginning makes no sense. What branch of science sits and tells you that if you go to bed tonight, your hair will look better in the morning? Now, my hair never looks good because it's my hair. But most people spend a lot of time with their hair. What branch of science tells you that things become more complicated and specialized and organized all by themselves? I can't think of one. We talk about the laws of thermodynamics, that energy cannot be created or destroyed, and all things tend toward entropy. Entropy is disorder. Entropy is chaos. And so evolution is saying that when nothing became everything, as long as you give it enough time, it becomes complex and organized and structured. And I can't put that together because I had to learn every single enzyme, every single intermediate for cellular respiration. And it's really complex. It was an entire quarter of my life memorizing all the steps and intermediates and enzymes in cellular respiration. I don't remember a single one. But I did because I passed the class. So if something that complex can happen all by itself, then I need other branches of science to support it. And I don't see that. Darwin thought that cells were just little bits of goo. When we named mitosis and meiosis, we named them threads. We didn't even know what DNA was. We named all these things. We had no concept of their function. We're still learning about how incredibly complex and intricate things are. And it makes no sense to me that this happened all by itself. I cannot find any biological process that I know of that creates order, that creates complexity. Everything I know of creates chaos.
All right, so the main argument that I will hear from people who support the transgender movement is the hermaphrodite. Do those have either the XX or the XY?
I remember trying to Google that because I was trying to anticipate questions. And that's why I went through the whole thing about Turner, Jacobs, Klinefelter, and Triple.
Yeah.
That there are, and I don't want to call it, it's not a mistake, because the person's not a mistake. The person's created in God's image. We live in a world where things happen out of the norm. So the normal is 46 chromosomes, and then things happen outside of that norm. I did read an article about a guy that studies gender anomalies, and he defined males as having a Y chromosome and females as not having a Y chromosome. So I would have to read about hermaphrodites. It's not something I understand, but I did want to start with the height and the hands because not everybody fits into the perfect stereotypes. There are masculine guys, there are effeminate guys. There's masculine girls who don't wear makeup or wear jewelry and sweat and like working in the yard. And then there's women that are very traditional, feminine, beautiful hair and all that stuff. So you have this huge variation. We put everybody in a line. But not that many girls. This lady who's maybe a little bit above average height, does that mean all of a sudden she's a guy because she's tall? I'm taller than my husband. Am I the husband in the relationship and he's the wife because I'm an inch taller than him? No. It was more important to the traits he has control over on the inside than who his genetic traits were on the outside. I don't care how tall my husband is if he loves me and protects me and stands up beside me. And when I screw up, he says, we will fix this. It's when I mess up, he takes my problems as his own. And I don't care how tall he is. It's a man to treat me like that is amazing.
Thank you so much for being here tonight. We appreciate all that you have taught us. I know more science just from tonight than I did that I've learned over the last 45 years. So. And I just want to talk about a couple verses. In a chapter you guys are familiar with in 1 Corinthians 13. See, here's the thing. We know from the Bible exactly what Annalisa told us tonight, that God made them male and female. God made them that way. I have told you guys before that I have a transgender nephew. In Christmas of 2019, he announced it to the family that he was no longer going to be Jacob, he was going to be Jacqueline. And that this is the way the man upstairs made him. No. The man upstairs, if he was indeed referring to God, made him male. So, we know that there is male and female. I love the example Annalisa gave. That doesn't mean that there are like masculine men and less masculine men and vice versa with the women. But they're still male and female. I saw this video and this guy was an EMT. Steve woke up again. So, and this EMT was a trans. And he was talking to the speaker, and he goes, and he's trying to make his point of view that, the man can be a woman and vice versa. So the speaker goes, well, you're an EMT, if you're called out on a call, and a man is laying there, are you going to check if he's pregnant? The guy goes, well, no. Well, why not? Men can become women, women can become men. Why not? Why wouldn't you check that? Well, because he's a man. And that was this guy's point. So we know that. And we now have information, that shows that sounding brass or a clanging cymbal. And though I have the gift of prophecy and understand all mysteries and all knowledge, and though I have all faith so that I could remove mountains, but have not love, I am nothing. And though I bestow all my goods to feed the poor, and though I give my body to be burned, but have not love, it profits me nothing. How do we deal with the transgenders that we might have to approach? The same way that we deal with anybody that is in sin that we have to approach. With love. We have to have God's love for people. We cannot have this point of view that you are just the worst of the worst. I can't believe what you're doing. I can't believe what you're trying to say to me. I can't believe you want me to change my language. I can't believe you want me to do all this. We have to have love. We have to have God's love for anybody that we come across, that we want to minister to. Now, we can minister to people in a bunch of different ways. But we have to do it out of love. It's not easy sometimes. My nephew, who wants me to call him my niece, but my nephew can drive me up the wall. Because he not only believes that he can say he's a girl when he's a girl, but he also believes in a lot of weird stuff that is just so obviously just not true. But I have to have love for them. Because God wants them to be saved. It is not God's will that any would perish, but all would come to repentance. And I have to remember that, and we have to remember that as we go out into the world. I'm glad we have all this information. And what this should do is just kind of define that the Bible is absolutely true. God knew what he was talking about. God made men the way they are and women the way they are. And I thought the experiments were so cool because when everybody lined up, I didn't realize, oh man, the men are actually really a lot taller on average than the women. I mean, there were 6 women at the end. And, you know, I mean, with the hands. It's just so obvious that God made us this way. And even with all the pelvises and everything that Annalisa talked about at the end, yes, it's obvious that the women are made to have babies and men are not. We have all that. It confirms what God said. But when we deal with people, we're not going to be able to just throw all this information at them. Did you know? Show me your hand. We have to come at them with love. Amen?
Amen.
All right. I hope you guys enjoyed tonight. I really enjoyed it. It was a lot of information. It was a lot of good information that you don't hear anywhere. And are you going to stick around if anyone wants to talk to you for a little while? So if you guys have any questions that you didn't get a chance to ask her, she'll stick around for a little while. I mean, I know one of the things that I'd be curious about, and maybe you guys can talk to her about it, is now you have to be a teacher at Mount SAC who does not believe when you talk tonight, right? And you've taught, and she has talked to Pastor Jack, and you know, when it comes to teaching evolution versus creation, that's putting her in a tough place. So you might want to talk to her about those kind of things, or whatever you want to talk to her. But thank you again for being here tonight, and let's close in prayer. Father God, we thank you, Lord, for blessing us with this night and a chance to just see that you put so much work into your creation. That there are reasons for even the littlest of things that happen in our bodies. And that you designed them for a purpose. And we just praise you, Lord, that you have put Christian teachers in the colleges and in the high schools and in all schools, because these young people need it. And I just pray that you would continue to bless Annalisa, Lord, and I pray that you would just bless the rest of this night as we give it to you in Jesus' name. Amen. All right. Thank you.